Hello everybody. You may recall how in last week's tutorial I discussed kinematics, which is a study of motion without regards to force. However, beginning this week, I'd like to discuss real-world motion, which involves forces all the time. The most basic force you can mathematically understand and represent is the force of gravity, as it provides a constant acceleration provided you are near the Earth's surface, which for most day-to-day activities is very much true. An object under the force of gravity is said to be on free fall and can be represented like this. Where a downward pointing vector is used to describe the motion caused by gravity's pull. The exact acceleration is negative 9.8 meters per second, expressed negative 9.8 meters per second squared. The Earth is such a massive entity that even if you were very far from the surface, such as on the top of a mountain, this acceleration would still be true, as the mass would still pull on you at an equal amount. Because we can rely on the fact that acceleration due to gravity is constant on the Earth's surface, we can refer to the kinematic equations discussed last week and plug and play negative 9.8 for the A value to solve for things like initial and final velocities, positions, or time. One big exception that you should be mindful about, however, is that objects with large surface areas, such as a feather or a whiteboard, come into contact with the air more, so encounter more air resistance. So they will fall slower than areas with not as wide a surface area. You may also know about Newton's second law, which states that for any type of object acting under a force, the force equals mass times acceleration. And this is still true for any object under the force of gravity. Even though acceleration is constant, a more massive object will have a greater weight. Which means they'll have more inertia when bouncing off the floor, or more inertia in your hands, which translates to a heavier feeling. Force under gravity is called weight. So Newton's second law, when it comes to weight, would look like weight equals mass times gravity's constant. And force and weight are expressed internationally in the unit of newtons, although in American and United Kingdom standards, weight is expressed in pounds instead. In next week's tutorial, we will discuss horizontal forces, such as friction, and the forces that make wheels move easier and smoother over surfaces compared to objects without wheels.